G'day guys, I've got a really interesting one and I've seen this, it was put up on Facebook and got on the iPad here. I better find it. I hope it's still on the same page. Yes it is. Okay, this is about Minelab GPZ7000 and it's on the Minelab GPZ7000 Users Australia. I think that's what the group is. I'm just making sure. But anyway, this is a little statement from Minelab. I'll read it. We have identified a common fault across a number of GPZ7000 gold detectors recently returned to our service department. With further investigation, we have determined that the connection of non-approved coils caused these unique symptoms. The use of non-Minelab approved coils on your GPZ, whatever, 7000 can cause irreparable damage to your detector. We have identified the following external symptoms as being the cause by connection of non-authorized coils. Now, non-authorized. Okay, we'll keep going. Every time the GPZ7000, I keep saying ZZ because I know, Americans say Z, we say Z. So I thought ZZ sounds funny, but anyway. Anyway, when it's turned on, we'll just call it the detector from now on. How's that? A coil not connected message can be displayed on the screen. The detector will not properly ground balance or ferrite balance when the ground balance trigger is pressed. This balance point will then rapidly drift, requiring frequent rebalancing. If Minelab determined that the connection of non-authorized third-party coils have caused the fault, then the fault will not be regarded as a warranty repair, and the owner will have to cover the cost of the repair, which in our experience is likely to require replacement of the whole control box. I'm not joking. Okay? And it says which can be costly. Yes. I would say it would be. Okay. Be aware that got a dry throat. Hang on. Right in the corner there. That's what happens. Be aware, I'm not going to edit it, bad luck. Be aware that Minelab coils and Minelab authorized coils are designed and have been extensively tested to be compatible with the detector and to operate within a strict set of parameters. Detector coils are also individually calibrated and hold that calibration on an embedded memory device. Minelab strongly suggests to use only Minelab branded or Minelab approved coils when detecting with your 7000 detector, and to be wary of detectors that display the symptoms described above. Very interesting, isn't it? And there's a whole heap of comments, which, yep, as you can expect. Yep, I think it's taking, well, according to the comments, that they're saying it's taking aim at X coils. Guy here, Mick. I've been using X coils, making adapter leads for a long time, and have never balanced my 7000 with the ferrite ring. Okay, so he uses X coils, spiral coils. Yeah. I'm not going to go into all of it. But how do we get around this if these coils are causing this issue? Now, you've got to look at what is in the dongle. The dongle, the bit in the plug on a genuine coil or a approved coil, it's basically, as far as I can tell, it's just a cryptographic communication chip. I don't know if it. I don't know, and this is my opinion, just so I don't get the evil bone pointed at me. But my opinion is that it doesn't do much except say there's a coil there. So calibration information, I don't know. Like I say, I've read up on the chips. I don't know if they've got enough memory to do that. Calibration information. But the funny thing is that we've made dongles. Dave has made dongles, as in we chop the plug off and we make a little adapter from it, and we can stick any damn coil on. Not hang on, I better clarify that. We can stick any coil that's designed to operate on a 7000 on the detector. We actually had a fellow, and I won't say any names, who we did a dongle for, and he put a standard GP or GPX detector coil on the detector. Do not do that. It caused a problem and took out the black module, which has caused all sorts of grief for many people, me included, as I spent countless hours trying to reverse engineer within reason, or trying to develop something that could replace that black module. And you can't. The thing is, you can't get it apart. I tried everything. Look, I have been able. Well, what actually happened? I got it apart, but the way I did it, it busted up the fiberglass circuit board. It actually chewed all the resin out of it, and it just completely turned to a black blob of charcoal. Not charcoal, but just look. I don't want to say how it was done, because I think there may be a way of refining it to make it work. It's like I say, it's very hard to get any of these detectors from anybody. And I'll tell you what, I'm still chasing. There's someone out there. Look, I'm just going to say someone out there had a detector that got hit with an axe or a pick or something. That we were told about. We were trying to get hold of it because we could have used parts of that detector to fix another detector. And the lead went quiet. So I don't know what happened there. If you do have a stuffed up 7000 and it's just a boat anchor, let me know. We may be interested in buying it from you. That's what I can say on that. So, there are, things that happen to these detectors, and the the boards blow up and all sorts of things. And you know, sometimes you get told that it went to Minelab and they can't fix it, and it's going to cost you, you know, $6,500 or $8,000 for new boards. You can probably buy a detector cheaper on the second-hand market. As I've seen, I was told that people have been quoted. Let me have a look here. Someone has said this, and we'll just put this down to their opinion because I don't know if it's true or not. And it's where is it? I'll probably click the wrong thing. See, I put a comment in here as well, and you can probably read it. But basically, what I'm telling people, if this is only for very experienced people who play around with coils on these detectors. I'll read what I wrote, okay? And it said if you play around with the different coils, it is possible to add small fusible 0-ohm resistors on the data line, okay? The data line in the receiver input lines. So you'd have to know what they are. And you can also add diode protection on all the inputs. This on the receiver and the data lines, as long as the voltages are not going over the conduction voltage of the diode, okay, which is give or take 0.6, 0.7 of a volt, unless you use shotkeys and they're about 0.25, 0.3. You can put the diodes in series and you can increase the voltage drop, as in 0.7 will become 1.4 volts and so forth. It depends how much voltage or level is coming down. You don't want to clip that because that's all your information. And you want it so it's low enough that if anything comes through that's big, too much voltage amplitude wise, it doesn't go in and burn out possibly components in your black modules because you can't fix them. That is a problem, but there's a way, like I said, to get around it. On the receive and the data, you can use fusible resistors, 0-ohm fusible resistors. They're only good for a few milliamps, and if you actually did something terrible and shoved the transmit voltage in, what would happen is if it was diode protected on the far side of where that resistor is, that resistor will just go open circuit. And you can find that easy with a multimeter and you go, oh, okay, I did that and I took the resistor out. Normally that will not blow the detector up. It shouldn't. And, you know, it's basically protected to 0.7 of a volt with the diode. And if you shove something down there, probably you want 2 diodes, one connected forward bias, one connected reverse bias to ground, so you can get both waveforms. If it goes above, it goes pop or goes pop and takes out the protection resistor. That is what you want. On the transmit, I'm just talking about the 7 at the moment, on the transmit, you don't really want to put fusible resistors in the transmit because it is a constant current type transmitter that basically outputs in one polarity or one positive voltage and negative voltage. We can look at it that way. And if you short that out, it'll probably just take out the output driver transistors, MOSFETs or IGBTs, whatever they are. I can't remember. I think they're MOSFETs. And possibly also the drivers for those, as the gate drivers as well, which are FSD something or other, 26 something, 2610. I don't know, I can't remember. Close enough. But in all honesty, all you need to do on the transmit wires, if you want to protect them, is get some nichrome fuse wire or very, very thin fuse wire, not a fuse with big metal clampy ends on it. You don't want that in the detector. They actually can sort of be energized and give off eddy currents just because of their physical size. That can happen. So what you want to do is you want to put fusible wire on the transmit output. It's just 2 wires, the 2 thick ones. And if you do short it out, you know, what current goes through that thing, it's substantial, but you can measure it. You can get a clamp meter and just clamp one of the wires and measure the current, the peak current going through it, and just size your fuse wire to that current. You've got to keep it short. You can't be have any voltage drop on the fuse wire, because the coil in the transmit stage has to be like powered and steady state. It can't go, oh, I'm going to drift off downwards or whatever. It's got to be steady state, otherwise the detector will become noisy. But you can protect your own detector, and I would suggest doing this on detectors out of warranty, because if it plays up during warranty and you send it to Minelab, they might have a hissy fit over it because it's been fiddled with. That is probably the truth of the matter. But you can do this. Someone, if they really, really wanted to, could probably make up an adapter, even with a dongle as well, and inbuild into it some way of putting small fusible resistors and fuse wire in the dongle. So if you accidentally stick a damn normal coil in it, it's just going to pop the fuses. It's not going to blow the detector up and cause massive damage. That's a good way of looking at this. You can protect it. There's some interesting things that people have done. I've seen it happen in the past where things have been connected wrong, and you've got to be very, very careful about the blue wire. The blue wire is a floating ground, which is the shield of the coil, and it runs into the board, and it doesn't actually just go to ground. It goes to other things. And I know people have put voltage on that and blown up the module. So do not do that. There's some very interesting comments here. I'm not going to read them all, but most of them are having a stab, as they do, having a bit of a poke. I can't change that now. I wanted to have a look at, oh, hang on, here we go. Most relevant. I want to make it most relevant. Most relevant, please. Oh, my post is most relevant as a reply now. For some reason, I don't think it was, but most relevant. How about newest? And then back. Okay. Yep, they're all having a stab on the lack of available different type of coils. That's mainly what it is. As a fellow here says, a standard 14 and 19 is pretty much all you need. Well, I can tell you right now what you can do if you're bloody heavy, overweight 19-inch coil. You can, yeah, chop the cable off and use it for another coil. But if you have a look at the way these are done, the coils, the transmit coils, very, very low ohmage. I think it's still around about 300 microhenries. Maybe a little bit less, might be 280, 300, doesn't really matter too much. And the outrigger coils, the 2 receive coils in series, are made of very, very fine Litz wire. And I think they're, I think from memory, they were 200. Well, I only looked at a X coil, but the X coil would have based it on the Minelab design anyway, of course. And I think they were 208 microhenries each. And they're just in series and connected to the receive line. And yeah, the blue wire, I'm pretty sure is, as far as I can tell, I've only sort of glanced over it and just done poke prod here and there, is just connected to the shield. Do not let that touch anything any other wire whatsoever. Don't let the shield short to the transmit or any of those receive lines, because they are data lines, and if you put stray voltages on them, something may happen. So that's what I was saying about the diode protection. The input chips for the the cryptographic handshake chips, I think they work on 3 volts or 3.3 volts. So maybe you don't want a diode on that line because it's 0.7 of a volt and it wants to send data at 3.3 or 3 volts or somewhere just under that. Maybe you could use some sort of transil, they call them, or not a transorb, they are too rubbery. But you can get protections in a diodes that avalanche at a particular voltage. So on that line there, you'd say, well, how about we avalanche it at 4.5 volts? So if something goes down a 3.3 volt line, and you're trying to shove 30 or 40 volts into it, or back EMF, or not much back EMF, but if you're going to whack it with a big piece of voltage, that transil device will basically short out, and if you have a little tiny fusible resistor in front of that on the line, the current's going to go into that, and that resistor's not going to be able to handle it, and it's going to pop, open circuit, and it should protect your detector electronics. So I'm just putting this out there that it's basically Brad from Minelab has written this up, and yeah, basically people are, according to Brad, people are blowing up their detectors by using non-approved coils. In my humble opinion, a coil that is built correctly, there's no short circuits and there's no receive lines, data lines, or anything touching the transmit lines, or the shield's not touching the transmit lines, and it's all separate, in my opinion, will not blow up the detector. It is made to drive a very low ohm coil, probably 0.2 of an ohm or something, and around about 280, 300 microhenries. Actually, I do recall, I think I did measure the X coil, 305 microhenries, and the little outrigger coils each were 208. I don't even think that is a hard and fast number. And the other thing too on the receive coils, because they are in series, you need to damp each coil with a small resistor. And the smaller the better, and you want to encase it inside a powdered iron or ferrite structure that doesn't impinge on the operating frequency of the detector, as in you really don't want it to impinge on the decay rate of targets, and you don't want it to impinge on the transition rate, the switching frequency rate of the detector, otherwise it will cause losses. It's not hard to do. I definitely use the powdered iron cores because it's like the ground, and it's not an offset to when you ground balance. It's all sort of what's the word? Homogeneous. It's all 1-on-1. You don't want to have various different types of things that look like ground and decaying and behaving in different ways. The detector may get confused. It may throw the gold baby out with the bathwater, which is the dirt, as in mineralized dirt, may not register it properly. So you want to have a good look at stuff like that and do testing. But there is a lot of comments there. I'm pretty sure that's hang on, just make sure I'm on the right. Where are we? Yeah, it must be. It's funny, I can only get onto the post because I'm clicking on other people's likes on my comment. It just comes up. Yeah, it's the site is called Minelab GPZ or Z 7000, as in just 7000 users Australia. And I think if you type that in on Facebook, you will find it. I don't know if you have to join to see or what the story is, but if you go there and join up, they'll be very happy for the extra membership, I think. So that's that. All good. So I was just putting this out there. Minelab have identified it. I'm just reiterating what they have said. And rather than stopping experimentation and causing issues, there is a way around it. There is definitely a way around it so it doesn't happen. And I know someone who wish that they actually probably had something like that done to their detector before putting a wrong coil in it, because it's one of those things, it is just too easy to do. You tell people, do not do this. I actually know two people who have done it. So saying no names, not saying any names, but it's just embarrassing that you do this to your poor detector. So anyway, that's what's obviously been happening. They've been getting detectors in, and they're coming across this problem where it won't ground balance. It's very strange that would have to be someone. Look, I'm going to put it out there. Has there been someone out there, whoever makes dongles is going to hate me, but I'm going to say it because it's a consumer issue. Um, if you don't make the dongle properly, there's a chance it can blow up the detector, right? That's basically what I'm saying. If you don't make it properly, you can blow up the detector. Is that because the next coil won't work on a Minelab unless you get the original coil, chop the end off it, and then rework it and make an adapter. We call it that protection. You got to use our coils chip, right? In my opinion, that's what it is. You've got to use our coils, or else no, because I don't believe that the it's just my opinion. I'm going to say this, cover my proverbial, because I know some companies are very litigious and just have a funny attitude. That those dongle coil cables um, are supplied as a cable assembly to the other authorized manufacturers, and they make a coil. I don't think, and in my opinion, I don't think they have any way of calibrating the chip inside the dongle after they've made the coil. So I don't know what's going on there. That's just me looking at it logically and looking at it and just putting my opinion on it, because you know would I don't know, are those things you know differently addressable for different memory sectors in the chip? Would they actually let anybody outside of Minelab do anything in the programming that could um, escape? And anybody who gets it could then start programming these chips to go in any damn coil or work on any damn 7000. That would be the end game. So I think it's probably in house, and I don't know if you can do it on the. I'm going to just put it out there. If it can be done, and anyone knows that it can be done, you can put your coil parameters into these chips in the coil plug. Please let me know, because I am very skeptical. I am very, very skeptical about that. It's basically, as far as I know, as I've read up on the chips, I don't think um, that they work that way. I don't think maybe there's a few couple of kilobyte and something that you can put some sort of thing in there. You could probably tell it that it's a double D or a mono. That is quite possible. But I don't know, does it actually hold value? Does it sort of say, well, I have a self-resonant frequency of this, and my inductance is this, and my resistance is that, and my decay rate is this, and it's all known by that little chip. You can do that inside the detector, obviously, but I don't know if you can do it on a 2-wire chip. I don't know. I'm just saying I don't know, because I'm smart enough to know that I don't know, right? I don't know. So it's just a funny thing to think about. But yeah, just my opinion. I might be totally wrong. I think you might be able to program, put Windows 95 on that 2-wire chip. I don't know. I didn't design it. Got no idea. I doubt that you could do that, but you could put a little bit of information in there. But what information and how much information you can put in one of these little things. Yeah, I think I did a video on them anyway of those chips. It's just a handshake thing. They go, hello, hello, handshake, yep, work. And it goes, hello, oh, there's nothing there. No, not going to work. No coil connected. So, as far as I know, and logically, it's just a thing that goes in there that stops people using other coils. That would be the main aim, wouldn't it? Why else would you do it? I suppose if it did have that, extra memory for, the functionality, the parameters of the actual windings and that. Yeah, I don't know, make any difference. Well, the thing is, I've built so many damn coils for these things, and I've used the existing dongle out of a mono coil on the adapter that David made, and I've made all sorts of stuff and just built them up on the floor and all sorts of. Never had a problem. Ground balance beautifully, do everything, don't care. Picks up targets, make a small one, super sensitive, works really well. Make a big one. It's pretty well. It's still pretty sensitive because it works like a double D, of course. It's got that winding overlap. Two of them. That's why the blip, 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 blip as you go over things, the double blips. And overall, a coil's a coil. It's not magic. The only thing where you get extra out of a coil is, like I say, you've got to give up something to get something else. And there's no free lunch in coil design. You just change the available electromagnetic field to go here, go there, do this, do that. But there's no boosting or anything like that happens. It's just either spread out or it's concentrated. That's all it is. It's either that big or it's that big, or it's long and skinny, or it's big and round, or a square shape, or whatever, or something like that. But I have noticed with some of these new coils coming out, and tell me if I'm wrong, I really should run it down to the vets and get it x-rayed to make sure. But I've done a bit of mapping just with a Hall effect sensor, and it seems like the windings at the front of the coil and the back of the coil, more so at the front of the coil, and it could be just that I didn't measure it properly towards the back because I wasn't really interested in poking at the back of the coil because the shaft was in the way, that somehow the winding comes around and then goes to a point inside the coil at the front. I'm not 100% sure on that, but they're extremely sensitive on the front of the coils. And it's not magic, because if it was a perfectly round coil, it would be that sensitive on the sides, and it is not. It's not that sensitive on the sides. It's sensitive right at the front of the coil. So it's just a geometry thing. So, like I say, there's no free lunch. If you bring it in the front and it's brought in at the back, and the sides like that, well, yeah, the sides are going to go down deep, but the ones at the front and the back aren't. So you're going to lose depth capability by trading that off for sensitivity. That's just what it is. So always said a full round coil will go the deepest on a given size target. Like, I'm not going to say that it's going to go on all targets, because if you've got something in the pinhead, something that comes in on the front like that's going to be really sensitive to it. But if you got a target where it was big enough and far enough down, and it was actually getting picked up by the bits on the side here, okay, and it basically was picking it up, well, these bits here aren't doing much. So what happens if you opened it up and made it the full size circle? I guarantee you that the signal level from that target that you can just hear will come up twice, because it's deeper, and then but you won't get the small stuff. So it's all trade-offs. The whole lot's trade-offs. It's no magic whatsoever. There's no magic in it. So you could probably, I tell you right now, you could probably get an old commander coil. So I'm going to get pooed on for this. You can get an old commander coil mono, right? And just if it's not done in resin, some coils are done in resin and it's so brittle that you try and do anything with the coil, it just snaps and all the windings are gone. But you could actually just cut the windings out and wind your own coil, and just copy the round bit. But when you get on the front and the back, you just bring it in to a nice, like the top of a a 10-pin bowl skittle or something like that. Just bring it in a bit, and you'll start getting that same effect as the newer coils, because I'm pretty sure, in my opinion, that is what they're doing. So, everyone's going, oh, they're very sensitive. Yeah, but do they go as deep on bigger targets? That is the question. And as we've seen over the years, the game plan has been generally to keep the punters happy by finding gold, no matter how small the gold is. So if you go out and you don't find gold, you'll be really, really pissed off. Well, people, go, they carry on like pork chops, of course, and they whinge and all the rest. I hear it. I hear it from prospectors. And, if you go out and you find, fly specks, even though gold, fly specks aren't worth that much, maybe, $1 or $2 or something, it does add up nowadays. But as long as the punters are finding something, the complaint level drops way down. It drops below the noise floor. So it's quite funny in that regard. It really is. So, you got all these metal detector companies out there and coil manufacturers and that, and they've all got this spiel. And, the average Joe Blow won't know what they're talking about. They'll just get something small and go, wow, that's sensitive. Try it on the side. do that. Try it on the side of the coil, not just the front, because it's a habit people do with monos. They'll just use the front. But try it on the side, and you go, hey, where's it gone? I can't hear it anymore. Unless you're in close proximity to the actual coil winding, you're going to hear it. But lift it up a bit and try it, and then try it. You may be in for a bit of a surprise. So, is that the way the coils are made? I don't know. There's something going on. It might be my imagination, or something like that. Might be might not be real life. Might have had a dream about it or something and think it's real. I don't know. But it's a good idea if you do these tests yourself. Like I had a coil here, one of the new ones, right? Just come out, and the guy said, "Oh, you can pull it apart if you want." I said, "No, I don't want to pull it apart. I just don't want to do that to a new coil." I've had a couple of offers of people saying just pull it apart. You can pull it apart, but and if you're very, very careful, you can make it look like it never come apart. Believe it or not, you just need a little bit of acetone, and yeah, you can put it all back together nicely. You got to be careful how you do it. Don't lose material. Basically, that's what the trick is. Don't lose what's there, and you can use what's there to basically remelt it. It just looks exactly the same if you're very careful. I shouldn't have said that because people are going to pull their coils apart and blame me when they stuff it up. Yeah. So yeah, that's all I wanted to talk about was these detectors blowing up. If you're blowing detectors up, guys, I don't know what's going on out there. I don't know everybody's story. I don't know. Not everyone sees these videos either. So just got to be wary. I'm just doing this for an education thing. So don't blow your detectors up. I'm just trying to educate people that there are ways that you can, if you are an experimenter and you like mucking around with coils, there are ways of protecting your investment that you don't blow it up and get something like somewhere between a $6,500 to $8,000 bill for new boards. New boards. So I'm not going to get into the board situation because it'll cause controversy, and I will get roasted over it. But yes. I'll give it to you this way. You got something here and something here, but they're like this, and this one gets damaged. Does that one get damaged too? Quite interesting, because I was told the boards aren't interchangeable, but I've interchanged so many it has no damn effect whatsoever. Not that I can measure. So I've got don't worry. I don't really want to get into that, but maybe something's not working properly, and I just don't know. But I haven't worked out what that I don't know is yet. It could be. I don't know. I don't know. Maybe it activates a countdown timer and the whole thing blows up in 30 hours or something. I don't know. I have no idea. So yeah, I'm just saying things as I've seen it. I've done it, and I didn't see any adverse effects. I didn't see it. It may be an adverse effect, but in my opinion, I don't think so. So it is what it is. It's like it's who made all the money in the gold rushes? The guy selling the picks and shovels. Um, so, just I think I've been in this game too long. I think that I have to retire and get out of it. I really do. I got to stop it. I got to do something else. Well, I should do something else actually. I could let you in on a little secret or something or other, but we'll put it this way. I don't have to work anymore if I didn't want to. Put it that way, okay? I don't have to. Things have happened, and I could go and live on a desert island for the rest of my life, or anything like that. I don't need to work, but I am because it keeps it. People rely on me doing this, as you may know, and I can't sort of just walk away from it. Even though I'd like to give it up and go detecting instead, but I can't. I just can't. I can't get away from this detector business. It's just it's if I don't do it, who else is going to do it? Okay, who else is going to do it? Do you know anybody who wants to get taught how to do detectors? Um, it's amazing. I'll tell you a story. This is a good one. Let's go and put this on as a little bit of an ending thing, right? And it just shows you the state of play in today's world. Okay. I knew a fellow, and he had a shoe repair business. And you'd think, there's no money in that. Oh, really? There's no money in that. Okay. Not everyone wants to wear, I was going to say some choice words, but Chinese mass produced, sneakers and stuff like that. Some people want to wear good shoes, and they are out there. Otherwise, the good shoe manufacturers wouldn't exist. And when your shoe stuff's up for whatever reason, you don't want to throw away your, $500 or $600 shoes. You want to get them fixed. And there was a big market for shoe repair. The guy I know had a business, and he used to make a damn fortune. But what he said, because a lot of it was polishing over a polishing thing, like a grinder on a stand, and he had to grind and polish and whatever else. And he said it started taking a toll on his back, but he'd been doing it for 30 years. And he said, what I'm going to do, he also had fish and chip shops, okay, and he had a couple of fish and chip shops, hamburger places. Actually, I think he had a place in Frankston that was called what's it called? Absolutely Cooked or something? I don't know. Anyway, the same guy, and I won't say any names, but Totally Cooked or something he called it, his business. It's quite funny. It's near the railway station. I can understand why he called it that. But what happened? He said to me, he goes, "Oh, do you know any kids want to learn, um, you know, doing shoes?" And I said, "I don't know." And he asked around, and no one was interested. And this is a business that you can make easy over $1,000 a week, $1,200 a week. Sometimes he'd make $1,400 a week. He told me all this. So it's a really good, profitable business. And he eventually advertised it around the place. And he said, no charge. You just pay the rent and you get the business and I'll train you. You know something? No takers. No one's interested. So the business is gone. So it's totally, you wouldn't believe it. No one wanted that business. No one wanted to learn how to repair shoes. Okay, and yeah, he said he'd give it away and train whoever wanted to do it. No takers. No one's interested. No one wants to work. Everybody just wants an easy dollar, corporately and everyone else too. Everyone wants the easy dollar. So yeah, it's just a state of play. I could probably say, look, I could train you to do metal detectors over a period of oh dear, it's something you couldn't train anyone to do from scratch. I'd tell you, it'd be hard. You've got to get the right mindset. It's not just a matter of just going, oh, I'll just do this and that. No, it's very touchy feely, careful. Don't do stupid things. Understand what you're doing, and all that to it. But you know, if someone wanted to do this, they can make themselves a small fortune if they wanted to. There's enough work out there doing this stuff. There is tons of work out there, especially on the custom detectors. We get a lot of people say, "I want it to do this," and you're sort of going to push it in that direction. And yeah, like I say, we got damn. I don't know how many detectors are done. I've lost count. There's so many that keep coming in each week. Bang, 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 bang. So it's just the way it is. Anyway, it's enough of a waffle. Got a terrible dry throat. Um, you can feel it right there. It's very dry, and probably this cold weather. There's no moisture in the air in this place. It's something like 4 degrees outside, and I've got a heater on. It's probably drying the air out more. The more you talk, the more your voice disappears. So yeah, I don't know. I don't know how long I'll stick around Ballarat for. Like I say, I don't have to be here. I don't have to work, and I can go anywhere in the world and just put my feet up and sip pina coladas the rest of my life if I wanted to. So I was letting you all know that, just because if one day I just disappear, you'll know that I've gone off and you know gone to live in the Philippines or something, or somewhere like that, somewhere where I've got a couple of blocks of land sitting there. Oh dear. Um, but all good fun. Philippines has lots of treasure too, and I'm pretty good friends with a couple of people that run particular provinces, which is very, very handy over there. So there's yeah, lots of people that you can go and have a chat to, on a first name basis, which is good. Yeah, that's probably about it. 10:30 at night, and yeah, I'm going to do a couple of emails and upload this video. So yeah, a lot of people don't see the videos because usually I do them earlier. I do them probably around about 5 or 6 p.m. But for some reason, I just get too busy and too tied up and doing stuff, and they're happening at around 10, 11, 12. You know, doing videos at midnight's pretty sucky, isn't it? That's pretty bad. But you know, otherwise I wouldn't get them done. So anyway, catches.